Yeah, so what did you guys get for p hat? 0.704? So for q hat would be 296. Cool, I like it. And actually, before, like I said earlier, what would n p hat be? And here's why I put that formula down there. If p hat is x over n, what is n times p? X. So that's, like I said earlier, 459 is np hat. So np hat is 459, which is good. Why? Because it's bigger than equal to 5. Kick ass. And what would nq hat be? It would be everybody else. 193. It doesn't matter. Both those are bigger than equal to 5. I like it. Check. So it's normal enough, so we're allowed to do what we're about to do, which is always good to know. All right. Do it and then find out later. It's not really that big of a deal. All right, so that's my little check, right? Check NP and NQ hat. And we got everything we need for the confidence interval now. So we got p hat, give or take this many of these new little standard deviation dudes. So we have, what goes here? 704, give or take 2.05 of these bad boys. 652. It's just so damn easy to make a calculator error on that error piece. Because you got to be careful. Only one parenthesis here, and then don't close it until you're done with all this stuff. Otherwise, you come out of the square root too early. Those of you with the newer calculators, your square root symbol extends, which is nice, and you know exactly what the hell's under there. Only makes sense. Well, those of us with the older ones, oh, too bad for us. Right? You guys should go and download the new operating system if you want to. So 0.704 plus or minus, what do you get for the error when you put this in? 0.037? All right. So almost what percentage off? 4%, right? I like it. So plus or minus 4 percentage points margin of error sort of thing. That's what we would put on the bottom if we were doing a study and we want to put it in the paper. Right? And we still have papers. So my interval would go from cool. So then we'd say we are
36.
I like it.
That the interval.
At this interval
66.7% to 74.1%.
66.7% to 74.1%
Contains the true percentage of voters who voted in the last election.
Phew. All right. So you're not done with the confidence interval until you've given me that statement. Now, and something that kind of drives me a little bit crazy is when somebody tells me there's more than one interval. You have to have two endpoints to have an interval. There's only one interval up there. The interval from this to this. Cool, I like it. I'm not an English teacher, though. I'm not going to bust you on pluralizing in the wrong place. But still, I want you to realize there's only one interval up there, right? This one. What about number 2? Anybody understand about part A? Does number 2 have anything to do with number 1? We're talking about an entirely different subject here, right? And number 2, what's kind of evil is I haven't done I don't know what P hat and Q hat are. So if you don't know what the percentage of like men in the room over here, what's our best guess? 50%. That's our best guess. Now, a little more mathematically minded, let me show you this. If you look at the formula for N, making P and Q both 50% makes sense for 2 reasons. One, it's my best freaking guess. I have no idea. 50%, it's my best guess. You with me? Split the difference, 50%. Secondly, making them both 50%, 0.5, makes n the biggest it could be. So why does that make sense? If I don't have a clue what the percentage is, I should have to be forced to get the largest sample I would have to. If there's something that I don't know about the study I'm conducting, I should be forced to get a larger sample, the largest sample I'd have to. Does that sort of make some sense? No. Shit. So, if I know what these are, then n could be smaller and I can go just get that many. That's part B. If I don't have a clue what these are, I should be forced to get the largest sample I would ever have to get to cover myself for not knowing something. So in the book, you'll see two formulas. You'll see this one and you'll see this one. Where the hell does 0.25 come from? If you make that 0.5 and that 0.5, what's 0.5 times 0.5? 0.25. I love it. So don't let the book freak you out. What the hell's this? What's your best guess? If you don't know either of these, 50-50. So you'll see that formula, that's where it's coming from. It's not a new formula, it's the same damn formula. So what we do then is, what confidence level do I want to be at on number 2? 99%. And what's that going to tell me?
1%.
Careful. Two things going on. Where does this come from? Where's the z-score come from? Where's the z-score always come from? How confident I want to be, right? Where's the margin of error come from? What tells me the margin of error? What tells me what the error is? What's the magic word for the error? Within. I want to be within so much. It tells me the error, right? I want you to be very careful because it's a little evil because they're both percentages, right? The z-score comes from how confident I want to be because that tells me how far out I want to go, right? The more confident I want to be, the bigger the z-score because the further I have to go out. The error comes from how far off I want to be. I want to be within 3 percentage points. So that means the error will be 0.03. So let's see. I know the error is 0.03. Now this is nice. I said I want to be 99% confident. Who's got the z-score for that? You can look at the t-chart quickly, right? Yeah, if you look at the t-chart, it'll be that, which is actually a little bit more correct. Look at the z-score chart. The best they can do is split the difference. They'll make it 2.575. If you look at the t-score chart, now, again, you guys have got to continue keep the skills from before going with you. How do I use that t-score chart for this? If I want to be 99% confident, how much is outside in two tails? How much will be outside in two tails? 1%. So if I look at the column that's got 0.01 in two tails, and I go all the way to the bottom. If I stop, I get a t-score. If I go all the way to the bottom, I get a z-score. And you should see 2.576 at the bottom of that column. All right, so you look at your t-score chart, go to the column, it's got 0.01 in two tails. Why? Because it got 99% in here. There must be 1% outside. You look all the way to the bottom of the chart and you see 2.576. That's a z-score. All right, so here we go. T-scores were invented to cover my ass for when I don't know the real standard deviation. But if my sample is large enough, which is what the word large on that really means, then my standard deviation of a sample is close enough to my real standard deviation. Then t-scores aren't really needed anymore. They just become z-scores. The bigger my sample gets, if you go down any column, the smaller the t-score gets. It's less and less needed. The bigger my sample, the more sure I am about the standard deviation I get. The less sure I am about something, the bigger the t has to be to cover my ass for not knowing. But the bigger my sample gets, the smaller t can be. So if my sample is large enough, all the way at the bottom, I could just use a z-score. I don't need t-scores as much. I'm really certain about my standard deviation that I get. Cool, I like it. So that's why on the t-score chart at the very bottom, there are z-scores. It's kind of nice. cool. All right, so then I get the 2.576. If you use 2.575, that's fine. That just means you looked at the z-score chart. I can't knock you for that. That's beautiful. Okay. So we got everything we need. I know my z. I know my e. And what am I going to assume my p hat q hat is? Because it's going to be 50%, 50%, right? Half of a half is a quarter. And if I do this work, it'll tell me how large. So if I take a sample of 652, I was off by 3.7% for that number one problem, right? This is theoretical. This is saying, how many would I have to go and talk to be within 3%? So who's done this? Who's got this number? 1843.24? 27? Doesn't matter. What do you always do with that number? Go up, because you're talking about people, right? So you'll have to take 1844 people. 1,844. So if my boss wants me to figure out within 3 percentage points something, or how people feel about something, I've got to go talk to that many people. This is why we do preliminary studies. So look on part B. So is everybody decent with part A there? So again, when you don't know P hat and Q hat, and the weird thing about NPQ problems, the problems in the book are going to be smaller than they ever were. It's going to feel like they didn't tell you enough. I mean, look how short that problem is. I haven't told you much of anything. I don't have to. It's weird. Part B says do the whole thing again, but now I know what P hat is. Right? For part B, what's P hat? 31 out of 42. That's some units. And what's 31 divided by 42? 0.738? Okay, cool. All right, so then what's Q hat? I like it. Kick ass. Now this is interesting. Here I didn't know. I had to guess they were 50-50. Now I took a little study. 42 people. That's quick. I could do that pretty quickly. Get a feel for what it is. And then I could see what my end really has to be. This is like a worst case scenario. So if I just get a little bit of information, I can improve this. I'm like, I don't want to talk to 1,844 people. So if I do a little study, now I can say, do the same formula, but now I don't put 50-50 in, I put what they actually are. And I still want to be within 3%. Let me stop there for a second. You guys, that's the only difference between part A and part B. Part A, I had no idea. So I had to guess 50% each. That's my best guess. Part B, I have some idea because I took a little study. Took a little group of people. Oh, yeah, sorry. Yeah, thank you. Bless you. Gotta rely on you guys because my calculator is currently filming. What do you guys get for that? 1,425.6. So if I round up to 1426,
So I was writing this number.
it's a little bit better. It's 400 less. Still a lot of students, but 400 less. I could deal with that. So of course, the little thing, if I say how many more students, you can subtract the 42 that we already talked to, right? and see how many more I would need. So that'd be 13, something or other.
1384.
Oh, yeah, take away that 0.6.
Yeah. 1384.
Yeah. All right, so this is a very nuts and bolts kind of day today, right? The next kind of thing I want to do, I like that. I started saying something amazing. You'd think I was going to let you guys go. If I create confidence intervals, I can compare them. We sort of did this before. If I create a confidence interval, I can tell. It shows me evidence of what it isn't or what it might be, right? So, if I make a confidence interval and I get that. So say this is a 95% confidence interval for the true percentage of people who will vote for someone other than Bush or Clinton. Maybe Rand Paul, somebody else. Libertarian candidate, you never know. All right, you keep playing, he's got to win something. Then I'd say, could it possibly be 30% of people? So what would our study say about that? Is this evidence that it could be 30%? This is evidence against that, right? At a 95% confidence level, I'd say it looks like it's not going to be 30% of the people. Now, where people make their mistakes is you'll have polls that are taken that don't include last-minute decisions people make. So you'll see stuff on the news, something like 47% will vote for Bush and 44% will vote for Clinton. And two things they don't take into account. Number one, there's still people that haven't really made up their mind yet. Or they think they made up their mind and they didn't really. They changed their mind, right? And two, you've always got the bottom that's plus or minus 4%. So given this, could these be the same? What would the confidence interval here be? Let's see if you guys can do this. It's sort of backwards. They've already done the work, they gave me this. But if it's plus or minus 4%, what's the confidence interval for Bush? Yeah, it's 43 to 51%, right? That's what it could be.
Right.
What about for Clinton?
44 to
40, careful?
48.
Careful. 40%
48.
or 48%. So could they be the same percentage? Could Clinton actually be in front of Bush? Yes, Clinton could be 48, Bush could be 43, right?
Always.
You guys, you with me a little bit here? So, I mean, when we see this, sometimes the real evilness of this is when people go, well, then I'm not going to even go vote because my guys don't even have a chance. And that really sucks because maybe the reality is completely turned around. So people very often don't even think about this. Or they just see that and they go, that's just them being careful. They don't even realize that that's actually, you've got to create a little confidence intervals. So look, so this is not evidence. That is not evidence that more people will vote for Bush. Because they could be the same. These overlap. So that is a very quick test of a claim. If I claim that more people will vote for Bush, that's evidence that I'm not correct. You can reject my claim. Right? So let me show you one thing real quick and then I'll let you guys out a little early. I want to show you one example of this in real life. For right now. Real quick, do you guys hear that they found water underneath the surface of Mars?
Yep.
It's frozen, right?
Yeah, it's permafrost, really. It's like water you would never want to drink, but it's there.
Can be filtered.
They also selected the first people that would live there, right?
Yes.
1,000 or something.
I don't know about that whole expedition. I feel bad for those people.
They're gonna die.
You know, like 300 years from now, we'll have an expedition go there in 3 seconds because then
Yeah.
we'll figure out how to, and we'll find them, their remains or something. It'd be horrible. Little tombstones all over the place. You never know. Maybe they'll be all right. Maybe they'll actually get all figured out.
Yeah, Stephen Hawking says we're supposed to. We have to leave the planet for the survival of the human race.
What's that?
Stephen Hawking said humanity has to leave Earth for survival.
Oh yeah, pretty much. Well, someone has totally screwed this up. That's too bad for me. I'll have to show you next time. So that's it. So next time we're actually going to have a little analysis to do between the males and the females in this class. We'll see if there's statistical significant difference between your average grades. Why not? Maybe we'll do some ESP testing. Not joking.